Today's lectures are about frame-to-frame relations in the FrameNet database. Here are our topics. First, I'll just briefly go over some practical matters. I'll talk about frame-to-frame relations, re-invoking the notion of frame element to frame element mappings. We'll have a look at the frame grapher, the visualization tool that FrameNet developed in order to view and explore the FrameNet hierarchy of frames. Notice that I said hierarchy and not ontology. And then I have a few more words about semantic information in FrameNet. Then we'll have a break, and then I'll turn it over to Michael. So our practical matters are, I encourage you to keep reading or reread chapter 6 in the book. There's a lot of information there. It may be difficult to absorb all at once. I believe it's worth reading more than once. I myself often go back to that chapter to clarify or remind myself, what did we say about that frame-to-frame relation? How are we using this semantic type? I should also caution you that we know that chapter needs to be revised, both in terms of the style in which it's written. Let's say we could do a much better job in presenting the material, making it easier to follow, and so on. It's a task that I've had in mind for quite a long time. Even more importantly is that we know that some of the information in there will be updated in the next version of that chapter. So if you hear me or Michael say something contradictory to what you've read, obviously I'd like you to ask, but the possibility exists that FrameNet now has a new and better understanding of the concept we were using than we did when we wrote chapter 6. Michael has a comment.
Also, if you could email me about, or Miriam, or both.
Both.
Or both, about what it is that's out of step about the book. That would be helpful. You know, I mean, sometimes we don't realize how we've moved on. So it would be great. Thank
Right,
you.
and more generally, having an outsider's perspective is useful because we're in the thick of it. So we often don't see what an outsider sees. Keep working at chapter 6. I encourage you to use the FrameNet frame grapher. I'll give you a bit of an introduction about the frame grapher in terms of what it shows you, what you get when you make a request, and how to move around in the frame grapher. And Michael will, of course, have even more for you. The last practical matter is that, as you know, after the break, Michael will take over. We'll be changing the guard. And I wanted to take this opportunity to thank you all for participating. Thank Tiago for making this happen, and for really making my stay here very enjoyable in more ways than you can imagine. I hope that those of you who have participated and in particular have come to office hours and spoken with me about your work. I want you to know that I'm available if you want to continue the conversation. You have my email address. You know how to get in touch with me. So thank you very much. Right, frame-to-frame relations in the FrameNet database. FrameNet records information, semantic information about how frames are related to each other. The ones that I'm going to talk about today are listed on this slide. Aside from describing each of these, I'll give you example frames that participate in these relations. For the most part, FrameNet papers discuss inheritance using and subframes. And at the end of the lecture, I'll list other papers for you to read that focus on one or more of the other relations. And then, of course, I'll give that list to Thiago, and he can post it on the course website. So if you can't access the PowerPoint, the PDF of the PowerPoint anymore, you'll be able to access that information through the website. The first frame I'm going to talk about. The first frame-to-frame relation that I'm going to talk about is inheritance. Inheritance is a relationship between a more general frame, which we call the parent frame, and a more specific frame, which is called the child frame. For each frame element, frame relation, and semantic characteristic in the parent frame, there is a corresponding entity in the child frame that is either the same or more specific. The key feature about inheritance compared with another relation, frame-to-frame relation that I'll talk about shortly, is that for inheritance, for us to say, evading inherits from avoiding, I have to have a correspondence between the frame elements in the lower frame, the child frame, and the frame elements, every single one of them, in the parent frame. So let's look at an example. We're going to be talking about the set of frames avoiding, evading, and dodging. Very briefly, avoiding is a situation in which an agent avoids an undesirable situation, which may be an event or an activity. Avoiding is a situation in which an evader moves under its own power to avoid capture or contact with a moving pursuer. Dodging is a situation in which a dodger acts to avoid an oncoming bad entity. The motion is relative since the dodger also may be moving. We can look at an example sentence here for evading. Remember, we said evading inherits from avoiding. Howard evaded the FBI. Howard instantiates the evader. and the FBI is the pursuer. Notice that the frame element evader in the evading frame enjoys the frame element to frame element mapping of agent in the avoiding frame. And the frame element pursuer in evading is mapped to undesirable situation in the avoiding frame. Now, this is just one example of two of the frame elements in each of the frames. For inheritance to hold between a parent frame and a child frame, there has to be a mapping from each frame element in the child frame to each frame element in the parent frame. So this is complete inheritance. Undesirable situation can be an event or an entity, including a person. However, pursuer cannot be an event. Pursuer can only be a person or an organization standing in for a person metonymically, right? In other words, as I said, we have a metonymy here, and next week you're going to hear more about metaphor and metonymy in FrameNet and what FrameNet currently does, which I indicated earlier this week, and some ongoing work now. Another example of inheritance, dodging inherits from avoiding. We have the dodger frame element in the dodging frame is mapped to the agent frame element in avoiding. And the bad entity frame element in dodging maps to undesirable situation in avoiding. Notice that bad entity is more specific than undesirable situation. We can have many different kinds of undesirable situations, and one of them can be instantiated in an entity, right? The role bad entity can be filled by an entity, right? The point, however, is that bad entity is more specific than undesirable situation. Earlier, we saw that undesirable situation could also be an event, right? Let's look at the frame-to-frame relationship we call using. Using is a relationship between a more general frame, the parent frame, and a more specific frame, the child frame, in which only some of the frame elements in the parent have a corresponding entity in the child frame. If correspondences exist in the child frame, those correspondences are more specific than the frame element in the parent frame. This is called incomplete inheritance. Here's an example. Evading uses motion. So the evading frame uses the motion frame. Motion is more general. In FrameNet, we talk about it as a higher level frame. In the hierarchy, it's higher up. The evader in the evading frame corresponds to the theme in the motion frame. And the pursuer in the evading frame corresponds to source in the motion frame. I'm going to show you what this looks like in the FrameNet frame grapher. The frame grapher, which is available to the entire world through the FrameNet website, is a tool that facilitates viewing frame-to-frame relations recorded in the database, and more generally, to exploring the hierarchy. We can see the frame-to-frame relations that I just described and illustrated with avoiding, evading, and dodging. This picture shows both inheritance and using. Conveniently enough, for my purposes, avoiding, evading, and dodging as a little set of frames, or a little subset of frames, because avoiding is actually a much larger family of frames, though here I'm focusing only on evading and dodging. As we said, dodging inherits from avoiding. Evading also inherits from avoiding. That's what the red arrow shows. Evading uses motion. That's what the green arrow shows, the green dashed arrow. Over on the left, you see a rectangular box that says 54 children total. That's all you want to have there. If you were to see all 54 children, regardless of their frame-to-frame relation to the higher level frame, intentionally act, you cannot make sense of any of it. Right? We're happy that all of that is there. Once you learn how to navigate through the frame grapher interface, you'll be able to pick which set of frames you want to look at, which relations you want to ask for to limit the number of arrows that you see, and how many children frames, how many child frames you'll see depicted. Okay? Notice that the frame that's at the center of our exploration is highlighted. One of the things that you can do with this tool is select a different frame to place at the center of your exploration. And you only need to click on that frame, or the oval that represents that frame, and it'll shift. You'll also have a record about which frame you started with. So you can always go back. And then, of course, you can always start all over again to limit, if you would like, to limit the number of frames and the number of generations, if you will, that you're viewing at any one time. Subframes is a relationship that FrameNet uses to characterize the different, typically ordered parts of a complex event. That relationship is represented in terms of the sequences of states of affairs and transitions between each part of the complex event. Each part of the complex event can itself be described as a frame. Later on, I'm going to show you a frame grapher representation of a very complex event with all of the frame-to-frame relations that hold between the different frames. And you'll see, first of all, how complex that event is, as well as how each of the different frames that figure into the complex event are related to each other, as well as to the top-level frame in that complex event. Before illustrating subframes, I want to describe precedes in no small way, because precedes figures in to frames that participate in the subframes relationship, right? Complex event, typically ordered sequence of sub-events. Necessarily, those sub-events will have some kind of ordering. Precedes precedes captures the temporal ordering of sub-events within a complex event. The relation holds between component subframes of a single complex frame. It also provides additional information to the set of subframe relations. Let's look at an example of subframes and precedes as they manifest in what we call the sleep-wake cycle. So, notice that being awake, getting up, fall asleep, sleep, and waking up are subframes of the sleep-wake cycle. Each of those events, or little mini-events, happen as part of this cycle that we call the sleep-wake cycle. As I said, each of those events that are subframes can also be described as frames. So if you go to the frame grapher and you click on being awake, for example, you'll see that frame at the center of your exploration. You can also ask the frame grapher to show you the frame definition for the frame that's under consideration, or the frame that's at the center of your exploration. So you don't have to go to a different place on the FrameNet website to see how is being awake defined. Right there in the FrameNet grapher, there's a button for you to select View Frame Definition. Okay? Each one, well, not each one. In the subframes, we have frames that are related to each other through the semantic relation precedes. So for example, being awake precedes getting up. Falling asleep precedes sleep, and sleep precedes waking up. Notice here that, excuse me, that being awake and fall asleep are related to each other with the precedes relation in both directions. Right?
Slight correction. The being awake precedes fall asleep, but it follows waking up.
This is from the grapher.
It is, but I'm just saying that that the arrow that you were interpreting as coming from fall asleep, going from fall asleep to being awake, actually that arrow comes from waking up, goes all the way across, and precedes being awake.
No, Michael, look at being awake.
Yeah.
And follow the shorter arrow on the top, and it goes to fall asleep.
There's one, the being awake precedes fall asleep, and then it goes the other way from waking up. That's all I was saying.
I think I'll show you on the depiction afterwards. Okay. If the FrameNet grapher is wrong, then it's wrong in the database, but right now, the FrameNet grapher shows a two-way arrow between being awake and fall asleep. We have another two-way arrow between being awake and waking up. Okay, let's go on. Next, frame-to-frame relation. Perspective on. Thiago, do you have a question?
No, just 9
Oh, okay. Perspective on is a frame-to-frame relation that distinguishes between neutral and perspectivized frames, the latter identifying different points of view of other participants in the larger scenario. The numerous frames, for example, in the commercial transaction family of frames include those that take, for example, the perspective of the buyer or the perspective of the seller. In which case we say, oops, that says precedes, it should say perspective on. In which case we say that commerce sell provides a perspective on commerce goods transfer, and commerce buy provides a perspective on commerce goods transfer. The 5 frame-to-frame relations that I just described and illustrated are needed for the employment scenario. For example, firing inherits from employment end. Employment start is a subframe of the employment scenario. Hiring and getting a job each provide a perspective on employment start. Hiring takes the perspective of the employer, and get a job takes the perspective of the employee. Likewise, employment start precedes employment continue, and employment continue precedes employment end. FrameNet has developed these large complex event frames for only a few scenarios. In principle, of course, we could develop the frames for many more scenarios, or we can collaborate with FrameNet Brazil, which is developing the scenario frames, for example, for tourism, playing soccer, right? FrameNet has a frame called touring, for example. In FrameNet, the touring frame characterizes a situation in which a tourist visits a tourist attraction. That is only one small part of tourism more generally, right? So I imagine that FrameNet Brazil will use the touring frame that FrameNet has defined. FrameNet Brazil will also define other frames that are immediately related to tourism that FrameNet hasn't defined. FrameNet, the original, as I like to say, can exploit the work that FrameNet Brazil has done and use those frames to develop the same or analogous frames for English in FrameNet.
Something that we have been talking about a lot, mainly Mausha and I, because of her work, is regards the perspective relation. Okay?
Yes, perspective on.
Yeah, because it's quite clear when you look at, for example, the commerce frames, you know, because you have different agent-like participants, like the buyer and the seller. So it's quite easy to look at them as different perspectives.
Perspective on.
Yeah, and you can also see the perspective of the money or of the goods in a very, very clear way. However, in some LUs or in some sentences of some LUs in the tourism big frame or the touristic scenario.
The tourism.
Yeah.
I suggested to Mausha that she call the largest scenario tourism, right? Because that's general. And then the other frames, whatever they are, touring or...
Yeah. So in those other frames, especially if we have what we would assign in a semantic type as an invited LU to that frame, so it's originally not. I know I'm bringing things you're going to talk about later.
Yeah, but it's okay. Ask the question.
For example, you have one verb in Portuguese, which is surpreender. Okay? It's cause to be surprised.
Surprise.
Yeah.
In English, it's just surprise. You can surprise. I surprised Thiago.
But probably you can't say New York surprises for its beautiful buildings.
You can.
You can.
Although,
or you could, more likely in English, you would say, New York's beautiful buildings surprise me.
Okay.
Something like that. But the point is that you have surprise as a, well, it's not a causative actually. It's an experiencer.
No, that's a it's a stimulus.
Oh, stimulus.
In that case,
right.
But there is also a causative version, and in both English and probably in Portuguese as well.
But the idea is the following: we were discussing whether we are going to put this kind of LU and sentence in a frame in which the tourist is core, or in a different frame in which it is not core. you know?
Right.
Because
so I think I understand what
since
you're asking.
yeah.
So, and correct me if I'm mistaken in my understanding. There is lots of language that you will find in any corpus that we might want to call part of the general vocabulary and not necessarily specific to tourism. So, tour as in tour the world or tour the sites of the city or something like that is a tourism word, right? But the city's beauty surprised me is not necessarily at all a tourism word. So the question I think you're asking is, how do we account for that word or make that word available in our multilingual resource? How do we make that word available to tourists, even though it's not unique to tourism? I think, I mean, there are many ways to go here, right? Surprise, the analog, the Portuguese analog to surprise will be in FrameNet Brazil, albeit not uniquely in the multilingual resource. But you want the multilingual resource to have access to that, right? So to some extent, I think it's going to build your database, right? But I think the approach that's most relevant here is that, and Michael, correct me if I'm mistaken, the approach that's most relevant here may be the one taken that Salsa took, the Salsa project took, the German Salsa project, where their initial goal was to annotate, to define and annotate frames and lexical units for an entire corpus. Necessarily, that meant they were going to come across vocabulary that FrameNet had not analyzed yet, right? It happened a lot. So remind me, Michael, exactly how they handled that. They had a separate category which they held off on the side, but they knew they had to examine.
Yeah, so they produced a category that they called unknown frames,
right?
Which they gave some relation to. In each case, the definition consisted primarily of like a sentence and a relationship, and just in prose, to the English FrameNet. However, just as a coda to this, I will say more about the semantic types, including guest LU, which is the one you're talking about, and we actually haven't defined very well how you should use the guest LU type. So I consider this to be one of the things I would love you to email me about that we should improve in the chapter.
All right. But in fact, it was not the question, but good answers. It's going to help.
Okay.
The question is the following. In a verb like surprise or offer, since I'm analyzing touristic guides, of course.
You mean the books, the language of tour guide, of manuals or brochures, or right?
That's the
tour
corpus.
Guides, tour
right?
guides. Yeah.
Since I'm analyzing this
or
kind of corpus.
Travel guides.
Okay.
Travel guides, we'd call them.
What I have is that, of course, the city is offering some attraction to a tourist. Of course, it surprises a tourist. Correct? But I cannot say that I have the perspective of the tourist. I, of course, have the perspective of the tourist attraction.
Correct.
Correct?
Yeah.
So our question is the following. If the tourist is inferable, and if I can see that it's always there, then it's core. Okay? It would be. I could posit no instantiations for the tourist in each one of those sentences, and it would be possible to infer them through context or to know that they are there or something like that, mainly because of the genre. Okay, because it's a travel guide and this kind of thing. But when I take a relation as perspective on, and I take commerce buy and commerce sell, then one thing that this relation does is turning something which is core in one perspective, non-core in a different perspective. So if it's commerce buy, then perspective of the buyer, buyer's core, seller is not necessarily, right?
I think in that case, both of them are core. But
yeah, exactly. In both cases, both are core because regardless of whose perspective or which participant's perspective the frame takes, in order to understand the larger scenario, you need all of them there. So it's not that it's not core. Perhaps it's less likely to be instantiated. Right, but it's still core.
Okay.
So both buyer and seller are core in commerce buy and commerce sell.
Does it go? Does it hold for money and goods also in the other perspectives or no?
Let's see. Goods are not actually core in the pay frame.
Right.
So not in buy and sell. So that's some more levels of distance because it's not just a separate perspective. It's also a separate subframe. But just to be clear, I'm going to go a lot more into perspective later on in the cognitive linguistic lecture, because actually the only way to define that stuff for real is to go a lot in. Basically, I think that perspective is an overloaded term, very deeply overloaded, and we have a very particular idea, or at least I do, that I'm developing about how to do that.
So I think the best thing to say right now is more to come. Right. I want to talk about two more frame-to-frame relations. I hinted at their existence in yesterday's lecture about reframing. We talked about FrameNet's lexicographic decision to define 3 separate frames for causative, inchoative, and stative words. And we, once again, looked at attaching, as well as inchoative attaching, and being attached as an example of one of the triples of frames that characterize these meaning distinctions. Such a triple of frames, attaching, encodative attaching, and being attached, also participates in 2 frame-to-frame relations, causative of and encodative of. First, let's look at causative. That characterizes an entity entering into a state, and one that portrays being in a state. To remind you of the types of sentences I have in mind for illustrating these frames, remember that attaching is the causative, and here's a sentence: the carpenter fastened the plank to the boat. Encodative attaching, she saw the tentacles fasten around her ankle. And being attached, the poles were fastened together. Attaching is the causative of encodative attaching. And encodative attaching is the encodative of being attached. Let's look at that in the frame grapher. So we have attaching related to encodative attaching through the causative of frame-to-frame relationship. And we have encodative attaching related to being attached through the frame-to-frame relation encodative of. Encodative of and causative of can actually be restated in terms of the other 5 frame-to-frame relations that I presented at the start. And you'll find out more about that next week. For now, you need to know that encodative of and causative of are different. They have a different quality than from the other 5 frames, from the other 5 frame-to-frame relations. FrameNet, as you know, has more semantic information. And we talked about the 2 labels that indicate incorporation and denotation earlier in the week. I want to remind you what those are and how they're used. First, let's talk about incorporation. Certain lexical units incorporate a frame element of their frame. FrameNet records this information, this semantic information, on the lexical unit. So if we look at the lexical unit shelve in the placing frame, as in the sentence, the kids shelved their toys, FrameNet labels the LU shelf. Oh, I spelled shelf wrong. Shouldn't it be shelf? Oh, I spelled it right. The lexical unit shelf has the semantic information incorporated indicate. Now remember, this shows up as part of the definition in the lexical entry report. You will not see it if you look at annotated sentences. So when you go to the FrameNet website and you select a frame to study and then you select a particular lexical unit whose annotations you want to see, when you see the annotations, whether you have the colors on or the colors off, you will not see the label INC there. Yes?
Well, I have a comment, and it's good that you brought this back, because it explains a mistake I must have made in this, the other assignment we had. Because in Portuguese, due to the possibility of constructions, the agents will usually be incorporated into the verb. In English, this is...
yeah, I know what you're talking about.
Yeah.
That's actually something else.
It isn't incorporation.
It is not incorporation. So Michael knows a lot about this because he spent a lot of time with Carlos Subirats working on Spanish FrameNet. I thought about this as well because Hebrew, like Spanish, like Portuguese, has a full-blown set of morphologically different verb forms. So you conjugate a verb for person, number, and gender in Hebrew. The concept is similar. In other words, all that the information packaged in the word form that you're considering includes information about speaker, number, and gender, right? So the notion is the same. But they developed another, I forgot what the label is called. Yeah, what is it called?
Can I just finish the response here? Basically, it's ECNI,
Right.
which means external constructional null instantiation.
Right.
And just to finish off what Miriam's saying, the reason why it's different is because incorporation means that the same information is present for this particular lexical unit all the time.
Right.
So shelve always involves a shelf, okay? Whereas when, for example, I take the first person singular of a verb, right, then it's only in that one form that we know that there's a first person singular. In the other forms, it's going to be a different pronoun.
Right. So
also, the point is that this is true across the entire vocabulary.
Right.
All verbs work the same way, so we factor it out as a construction instead of including it in the lexical information.
Right. So to the extent that you're looking at a word form and you have more information packaged in it, it's similar. To the extent that it differs from word form to word form, say in a conjugated paradigm, verbal paradigm, it's different.
So in traditional terms, can I say that incorporation would be that frame element that the root of the verb brings
Correct.
in itself?
Correct.
Oh, okay.
Correct. Right. And incorporation, we do use it only on verbs, right? Are there any other parts of speech?
There are other cases, actually.
Okay, we're not going to talk about them now. That's more complicated. But at least know that we use them on verbs. Okay. And denotation, FrameNet labels non-event nouns that are assigned a frame element with the label DEN, standing for denotation, also in effect indicating the definition of the lexical unit. Let's look at the example. Liana sifted through loads of information. The noun is load in the mass quantity frame. And the label, or the information that the word load includes denotation, appears in the tables of the lexical entry report. Like incorporation, you don't see this label if you examine the annotated sentences. Oh, you do see this. Sorry. Right, you see it in the lexical entry report. It does occur on sentences. I apologize. I'm going to spend a few minutes talking about semantic types, but as you already know, Michael will spend a lot of time talking about semantic types. So you'll have the opportunity to learn in great detail about semantic types, the different types of semantic types, and the different ways that FrameNet uses the different semantic types. For the short term, we know that FrameNet can indicate the semantic type of a frame element, a lexical unit, or even a frame. For example, the frame element cognizer in the cogitation frame has the semantic type sentient. So you don't imagine that a noun phrase that fills the role of cognizer could be anything but a sentient being, right? Every noun phrase that fills that role, every constituent that fills that role will be a sentient being. Of course, there are possibilities of metaphor and metonymy, but when you're considering literal usage, right? FrameNet marks semantic types on lexical units, if that's relevant. For example, FrameNet marks semantic type information on lexical units. For example, in the judgment communication frame, the lexical unit praise. John praised his son for his timely appearance at school. FrameNet marks that as positive judgment. Comparably, FrameNet marks the verb criticize with negative judgment. Recall that, at present at least, FrameNet has both words and their opposites, if you will, in the same frame. Recently, however, there's been a proposal to have a more fine-grained analysis for, let's say, negative or opposite in the vocabulary. At the moment, it's still a proposal. Doing so would, of course, mean a lot more work. That may well be worthwhile doing, precisely because those who are interested in using FrameNet data for work on inferencing would be happy to have that information as well. That is, to have that information recorded in FrameNet in a more explicit way. That reminds me that I can include in your additional reading, if you're interested, the paper that talks about that proposal. And lastly, where appropriate or relevant or needed, FrameNet marks semantic type on frames. For imagine, Michael is going to talk a lot more about that next week, at which time I imagine that the last section of chapter 6, which we haven't yet read, will be relevant. Here's a list of the articles that I think would be worth reading for very well articulated explanation of what certain semantic types, certain frame-to-frame relations are, with clear examples. So the first article by Nancy Chang and her colleagues talks about perspective. And interestingly, that article actually foreshadowed FrameNet's use of perspective on. So the article appeared in 2002, and it was only data release 1.3, I think in 2006, that actually had included the relation perspective on. Okay? The second article by Fillmore and his colleagues very nicely articulates inheritance, subframes, and the using frame-to-frame relations. And the last one is about precedes. And as you can see, that's hot off the press. Thank you very much.